Ever wondered how video games or virtual reality scenes create those lifelike 3D worlds? It's trickier than it looks. Traditional methods often struggle with making sure every part of a scene fits together geometrically, like a puzzle where pieces don't quite match. But a new breakthrough called IDC-Net is changing the game. Let's break it down. Most AI tools for generating 3D scenes treat color images, RGB, and depth information, D, as separate tasks. Think of it like trying to paint a picture and measure its dimensions at the same time. Messy. IDC-Net solves this by jointly learning how to create both RGB images and their corresponding depth maps together in a single model. This means the AI understands not just what a scene looks like, but how it's structured in space. Here's where it gets cool. The team built a super precise dataset of video clips where every frame has aligned RGB, depth, and camera movement data. Imagine a library of videos where each frame knows exactly where the camera was and how far objects are. This gives the AI a crystal-clear roadmap to follow. They even added a special, geometry-aware tool called a transformer block, which acts like a GPS for the model, making sure every generated frame stays perfectly in sync with the camera's path. The results? IDC-Net produces videos with unbelievable geometric consistency, no more wobbly walls or floating objects. And here's the kicker. These videos can be used directly for 3D reconstruction tasks, like building virtual worlds without needing extra fixes. It's like getting a finished puzzle instead of a jumbled mess. So why does this matter? From smarter robotics to next-gen gaming, this tech could make digital worlds feel more real than ever. Ready to see how it works? Let's dive deeper. Hey everyone! Ever wondered how computers can create realistic 3D videos that look like they were filmed with a real camera? Today, we're diving into a groundbreaking approach that's pushing the boundaries of AI-generated video. Let's break down how researchers are training models to create lifelike RGB-D videos. Think of it as teaching a robot to shoot a movie with perfect camera control. The key to this innovation starts with data. Researchers worked with two massive video datasets, RealEstate10K, 74,766 clips of indoor scenes, and DL3DV-10K, 10,000 clips with fast, complex camera movements. But raw data isn't enough. Imagine trying to build a car from a pile of random parts. They needed a smart filtering system to curate the best clips for training. First, they trimmed videos to the right length. RealEstate10K clips had to be at least 98 frames long, while DL3DV-10K needed 49 frames. Why? To ensure the model could learn consistent motion patterns without getting lost in noise. Next, they extracted synchronized RGB, depth, and camera pose data using advanced calibration techniques. Then, they applied a geometry-aware transformer architecture to model spatial relationships. And finally, they trained the network to predict future frames while maintaining geometric coherence. This pipeline's magic lies in its multitask learning framework. By optimizing for both visual fidelity and spatial accuracy, IDC-Net avoids the hallucination problems that plague single-task models. For example, when generating a video of a hallway, the model doesn't just guess where walls should be. It calculates their positions based on depth data and camera trajectories. This is achieved through a cross-attention mechanism that links RGB features with depth maps, ensuring every pixel's position is geometrically valid. The results? IDC-Net produces videos with unbelievable geometric consistency, no more wobbly walls or floating objects. And here's the kicker. These videos can be used directly for 3D reconstruction tasks, like building virtual worlds without needing extra fixes. It's like getting a finished puzzle instead of a jumbled mess. So why does this matter? From smarter robotics to next-gen gaming, this tech could make digital worlds feel more real than ever. Ready to see how it works? Let's dive deeper. Ever wondered what happens when AI gets creative with video? Let's break down some mind-blowing breakthroughs that are rewriting the rules of digital storytelling. First up, CogVideoX, a 2024 model that turns text into video. Think of it as giving AI a script and watching it act it out, frame by frame. How? It uses something called a transformer, a type of neural network that's great at handling sequences. Since video is just a series of moving images, transformers are perfect here. The result? Videos that feel smoother and more coherent than ever before. It's like having a scriptwriter that also knows how to direct a film. But what if we want to go beyond 2D? Enter Wonderworld, a 2025 project that turns a single photo into a full 3D world. Imagine taking a snapshot of your living room and asking, what if this space was a virtual playground? The model doesn't just guess. It uses depth info and object relationships to build a navigable 3D scene. You could explore it like a digital twin, with realistic lighting and textures. It's like magic but powered by math. Then there's ViewCrafter and VidCraft 3, which give creators superpowers for video. ViewCrafter specializes in novel view synthesis. Think of it as a virtual camera that can film a scene from entirely new angles. Watch a movie, but from the perspective of a passing bird or a floating drone. VidCraft 3 takes this further, letting you tweak cameras, objects, and lighting in real time. It's like having a film studio in your pocket, where every detail is adjustable. And finally, Stable Virtual Camera, another 2025 leap forward. While details are still emerging, early reports suggest it's about making virtual cameras more reliable and intuitive. opening doors for everything from immersive games to virtual tourism. These tools aren't just tech demos, they're reshaping how we create, explore, and interact with digital worlds. The future of video isn't just moving, it's evolving. Stay tuned for more updates.